Good day, my name is Bisente Cruz and I'm here to teach you about line coding, modulation, and coding techniques. So in first step, we need to learn what is line coding. Line coding. A line code is a code used for data transmission of a digital signal over a transmission line. This process of coding is chosen to avoid overlapping and distortion of signal such as intersymbol interference. So to put it simply, line coding is converting of binary data into digital signal. We all know that 1 is equals to on and 0 is equals to off. So here, our binary data is 110110. Since our first bit is 1, the signal will go from A positive for one whole cycle, and the next bit is another one which will continue its signal from A positive for another whole cycle. Then the third bit will be 0, which will make the signal drop to 0 and complete its whole cycle. Since our next bit is 1, the signal will rise again to A positive and completes its whole cycle. Another data is 1 that will continue its signal from A positive. Then 0 will make the signal go down to 0 and complete its whole cycle. Step number 2. Properties of line coding. When line coding is done to make more bits transmit on a single signal, the bandwidth that are being used is reduced. For a given bandwidth, the power is efficiently used. There should be immunity to noise and interference. There should be self-synchronizing. Both receiver and sender clocks should be synchronized. DC component can be eliminated. This allows AC, a capacitor or transformer, coupling between stages in telephone lines. Can control baseline wander. Baseline wander shifts the position of the signal waveform relative to the detector threshold and leads to severe erosion of noise margin. It also has error detection capabilities. Bandwidth usage, the possibility of transmitting at a higher rate than the other SIMs over the same bandwidth.
Ano yan?
Three types of line coding. We have unipolar, polar, bipolar. Unipolar. All the signal levels are either A positive or 0, which will vary in 2, which is NRZ and RZ. Next is polar. The voltage are on both sides of the axis. A positive or A negative, which will vary in NRZ and Manchester. Next is bipolar. There are 3 voltage level positive, negative, and 0. The voltage level for one data element is at 0, while the voltage level for another element alternates between positive and negative, which will also vary in NRZ and RZ. So what we need to learn right now is what is NRZ and RZ. Since all the types of line coding has NRZ and RZ, we need to learn what is NRZ and RZ. Also Manchester. NRZ or non-return to 0 is a signal does not return to 0 at the middle of the bit. Thus, it is called NRZ. So as we can see, for example, we have 1 and 0. If the data or the bit is 1, the signal will go from A positive and continue its one whole cycle in A positive. Then if the signal or the next bit is 0, the signal will go down from A positive to 0. And from 0, it will complete its whole cycle in 0. Next is RZ or return to 0. The signal goes to 0 in the middle of each bit. So as you can see, if you have input of 1, the first half cycle is going from A positive to half cycle. Then, the other half of the cycle, the signal goes from A positive Here, look at this. A positive and will go down to 0 and completes its whole cycle. Then if you have the input of 0, the signal will go from 0 to another half of the cycle, then completes its other half of the cycle in 0. Next, Manchester pulse. In Manchester pulse, at half duration, there is a transient from high to low or low to high. This will imply in polar type of line coding because 1 is equals to A positive, then 0 is equals to A negative. So as you can see, if you have input of 1, the signal will go from A positive for half cycle, then will go down to A negative to complete is another half of the cycle. Then the next input will be 0, which we all know that if in polar, 0 is equals to A negative. So here, the signal will continue its path from 0 or A negative to complete its half cycle, then another 0 for completing its another half of the cycle. Next, to further understand what or how can we shape the pulse, these are the basic pulse shaping techniques. In unipolar, the bit level is equals 1 is equals to A positive, then 0 is equals to 0. In polar, A is equals to A positive, then 0 is equals to A negative. Then in bipolar, A is equals to A positive or A negative, then 0 is equals to 0. In bipolar, the following signal will base or will depends in their previous data. So later on, we will discuss it more so we can understand. Example of unipolar NRZ or non-return to 0. Here we have binary data or digital data, which is 110, 110. So we all know that unipolar, in unipolar, 1 is equals to A but A positive, then 0 is equals to 0. So here, in the first bit, since it is 1, the signal will go from A positive and complete its whole cycle. Then another data is 1, so it will continue its signal from A positive here. Then the next data will be 0. So it will make the signal go down to 0 and continue its another whole cycle. Then the next data is 1, which will make the signal go rise up again to A positive to complete its one whole cycle. Then another one that will continue its signal from A positive. Then last one is 0, which will make the signal go down to 0 and completes its whole cycle. In unipolar RZ, we all know that if it's in RZ, the first half of the signal will go from positive, then to complete its whole cycle, the other half will be 0. So we have 1, 1, 0, 1. Since it is 1, the positive volt, the signal will go from A positive for half cycle, then its another half of the cycle will go to 0. Then another input is 1, it will rise up again to A positive, then completes its half cycle in A positive, then will go down again to 0 to complete its another half of the cycle. Then we have an input of 0, which will go from 0 to 0 in half cycle, then completes its another half of the cycle in 0. Next, we have 1, which will make the signal rise to the A positive for half of the cycle, then will go down again to 0 to complete its another half of the cycle. Next is the polar NRZ. In polar NRZ, we know that 1 is equals to A positive, then 0 is equals to A negative. So here, we have input of 110, 110. Since it is NRZ or non-return to 0, it will complete its one whole cycle. We have an input of 1, which will go from A positive to complete its whole cycle, then another 1, which will continue its another cycle in A positive, then 0, which we all know that 0 is equals to A negative. So from A positive, the signal will go from A positive into A negative and complete its whole cycle. Then the next data will be 1, which will make the signal go rise again to A positive to complete another cycle. Then the next data is 1, which will continue its signal from A positive upon completing its cycle. Then 0, which will make the signal go from A positive into A negative and will complete its one whole cycle. Next, next is polar RZ or return to 0. We have input of 1101. 1 will go from A positive for half cycle, then go down to 0 to complete its another half of the cycle, then rise up again since our next data is 1, rise the signal again to positive A for half of the cycle, then we'll go down to 0 again to complete another half of the cycle. Then since our next data is 0, we all know that 0 in polar type of the line coding, 0 is equals to A negative. So the signal will go from 0 to A negative, then completes its half cycle, then we'll go to 0 again and complete another half of the cycle. The last data is 1, which will make the signal go from 0, rise up to the A positive to complete its half cycle, then will also go down to 0 to complete another half of the cycle. Next, bipolar NRZ. In bipolar NRZ, we have input of 1, 1, 0, 1, 1. We all know that in bipolar line coding techniques, 1 is equal to A positive or A negative, which will depends on the previous data. For example, here we have 1, 1, so we know that the 1 is consecutive number or the 1 repeat from previous data. So it is a very good example for this one. We have 1, which will go from A positive. Then since the next data is another 1, the signal will go from A positive, go down to A negative to complete another cycle. Then the next data is 0, which will make the signal go from A negative into 0 and complete another cycle. Then our next data is 1. Since from the previous data we go from A negative, the next one or the next data, which is 1, will go from 0 rise to the A positive to continue one whole cycle, and another 1 in the previous data is 1. Since the previous data is 1, the signal will go again to A negative or the negative side of the axis to complete another cycle. Next is the bipolar RZ or return to 0. Even in return to 0, the rule which is 1 is equals to A positive or negative depends on the previous bit, which will also imply. We have input of 1, 1, 0, 1. The first data is 1, so the signal will go from A positive for half cycle, then go to 0 and completes is another half of the cycle. Since the previous is A positive, the next one will be A negative. So the signal will go from 0 to A negative, completes its half of the cycle, then go back to 0 to complete its another half of the cycle. Since our next data is 0, 0 or the signal will go from 0 to 0 for half of the cycle, then completes its another half of the cycle from 0. Next we have 1, and since we have the previous signal in A negative, the next one will be A positive. So the signal will rise from 0 to A positive, then completes its half of the cycle, then will go down to 0 to complete its another half of the cycle. Next is polar Manchester. In polar Manchester, we are not going to stay at 0 since polar 1 is equals to A positive, then 0 is equals to A negative. So there's no 0 in polar Manchester. So we have an input of 1, the first subcycle, will go from A positive and complete this half of the cycle, then will go down to A negative because 0 in polar Manchester or in the impolar Manchester is equal to A negative. So instead of going to 0, we are going to A negative. So the digital signal will go from A positive into A negative. Then the next input is 1, which will make the signal rise up again in A positive for half of the cycle. Then for another half of the cycle, will go down to A negative. To complete, it's another half of the cycle here. So the next input is 0. So we are going to stay in A negative since 0 is equal to A negative. So for first half of the cycle, the signal will stay at 0 or A negative, then completes another half of the cycle in A negative. Then the next input is 1, which will make the signal rise up again to A positive to complete its half of the cycle. Then will go down again to A negative to complete another half of its cycle. Then the next input is also 1, so it will make the signal rise up again to A positive to complete its half of the cycle. Then will also go down to A negative to complete its another half of the cycle. And that's all. I would like to thank all of you guys for hearing our presentations. And these are the people behind the video. First, Sir De La Cruz John Vincent. Next is Mr. or Sir Benavente Joshua and Sir Iri Angelo. Again, thank you and have a good day.